An introduction to DuckDB. What is DuckDB? DuckDB is a fast, in-process, SQL OLAP database management system. DuckDB uses columnar vectorized query execution engine and makes it very fast as compared to traditional record-based database management systems. In-process means the database runs within the same process as the application that uses it. DuckDB uses structured query language for querying databases. OLAP or online analytical processing means the database is designed for data analysis. Other types of databases are OLTP or online transaction processing. OLTP databases commonly store data by records while ensuring all data associated with a record is stored close together in memory. In contrast, OLAP databases are commonly oriented by columns. All data associated with a column is stored near one another in memory, and the database is optimized for reading and computing on the columns efficiently. DBMS, that is, DuckDB, is a database management system. Why DuckDB? Because it is simple, portable, fast, feature-rich, extensible, and free. We may download the DuckDB software from duckdb.org. DuckDB is available for different platforms such as Windows, Mac OS, and Linux, both for x86-64 and ARM64 architecture, and for different environments such as command line interface, Python, R, Java, Node.js, Rust, Go, C, C++, and ODBC. You may download the appropriate version as per your requirement. In this lesson, we will use the Windows command line interface version. Downloading the Windows command line interface. It's a compressed executable file. Decompress it and use it, as simple as that. Let's unzip the downloaded zip folder. Here is our duckdb.exe file. Just run this file from the command line. Now, our DuckDB program is ready for taking commands. By default, DuckDB connects to a transient in-memory database. Now let's create a table named Student with two fields, ID and name. ID is integer type, and name is string type. Let's see the tables. Our table is created, let's describe it. Now let's insert one record into the table. Let's check the records of the student table. Our record was inserted perfectly. Let's insert multiple records using a single insert statement. Let's display all the records. Now let's update one student's name. Name is updated successfully for ID equals 3. Now let's delete one record from the table. We have successfully deleted the record where name is Vinod. Let's create another table named Result with two fields, ID and marks. ID is an integer and marks is real or float. The result table is created successfully. Let's insert a few records into it. Let's display all the records from the result table. We have two tables, student and result. The fields of the tables are as shown on the screen. The current records are as shown on the screen. We will write a few join commands now. Before that, let's insert one record in each table. Now let's write a few join commands to show recording by combining the columns of the student and result tables. This is an example of inner join. We may explicitly write the inner keyword for inner join. Now check this left join command. Now check this right join command. Now check this full join command. Now let's check how to create persistent databases in DuckDB. We may mention a complete database file path as a command line argument to the DuckDB.exe program. In this example, student.db file will be created in the current folder. Creating a table named student inside the database student.db. Immediately after executing the create command, two new files, student.db and student.db.wall is created inside the working directory. Here, student.db is the actual database file and student.db.wall is a log file. WAL stands for write ahead log. We have already closed the command line interface. The database file persists in the mentioned path. Let's reopen the database and check the contents. We have already closed the command line interface. The database file persists in the mentioned path. Let's reopen the database and check the contents. As we can see, our previously created table persists. Let's close the command prompt and delete the database files. Now we will create the same database student.db in a different manner. Here, the persistent database file name is mentioned using the .open command of the command line interface. Exiting the command line interface. Use .exit command or press Ctrl+C or Ctrl+D depending on the OS. As mentioned earlier, DuckDB is a very powerful and full-fledged database software. We have already learnt the basics. It is not possible to cover everything in a single lesson. Now we will learn how to execute queries on .csv or .json files without creating tables or by creating tables from these files. Suppose we have a folder containing 3 files, 7a.csv, 7b.csv, and 7c.csv. The contents of these files are as shown on the screen. All the files contain data in the same format having class, section, roll number, name, and total marks columns. Now we will learn how to run queries on these files directly without importing these files in database tables. Let's display the contents of the 7a.csv file in a tabular format. And here is the result. Isn't it interesting? Personally, I like this feature of DuckDB very much. We are using a CSV file as a table without actually creating a table. We may also mention the column names that we want to display. We may also use the wildcard character asterisk for considering all the CSV files in the folder. Look, here the result comes from all the CSV files, 7a.csv, 7b.csv, and 7c.csv. Now let's explore the use of window functions rank and denseRank for ranking the students best on the total marks. If you want to learn the usage of window function, please write in the comment section below. I will prepare a new lesson on this topic, if you wish. Here, I am showing this just for demonstration purpose. We are nearing the end of this lesson. Let's consider that we have 3 JSON files as shown on the screen. These files contain the SWIFT codes for the banks of 3 different countries, India, United States, and China. We will run queries on these files from DuckDB command line interface. Lastly, in this lesson, we will learn how to create persistent database tables from CSV or JSON files. This is very simple, just follow me along while I execute the commands. Let's exit. That's all for today's lesson. If you find this lesson helpful, please don't forget to like, share, comment, and subscribe. Your valuable feedback is important for me and will help me improve the contents of the channel. Thanks for watching up to the end. Hope to see you in the next. Bye.